Hello, my name is Joseph Valenti, and I am the Vice President of Education of the Lumberg Project. Today, we're doing part one of Trig, any help on quizzes, tests, and questions that may come up in this area of math. So the first principle of Trig that we're going to go into, there's 7 main ones that you should keep in mind. This one's the 30, 60, 90 right triangle. So here's the right angle, right, perpendicular. And let's say this is the 30-degree angle, and this one's the 60-degree angle. Now, this is a common one because a lot of questions that you may see involve what's the sine of 30, what's the tangent of 60, what's the cos of 60. So this is very important to understand. It's actually very simple. It's just 1, 2, 3. That's how I like to think of it. So across from the angle, depending on the side, so the smaller the angle, something like that, the smaller the side length, right? So if I make a bigger angle, the bigger the side length, right? So that same principle applies to a right triangle like this. So across from 30, just a value of 1. Then across the right triangle should be bigger. 90 degrees is bigger than 30 degrees, so it's actually a value of 2. Across from 60 degrees, I said it's just 1, 2, 3. It would be radical 3, square root of 3. So that makes sense, right? We check ourselves. 30 degrees, smallest angle, lowest value length. 60 degrees should be right in the middle. This is radical 3, which is actually around like 1.41-ish. And then 2, which is 90 degrees. Across from 90 degrees, which checks out, which is good. So now in this scenario, if they ask, what's the sine of 30? And I recommend sine of 30 degrees. And I recommend you draw all these principles of Trig on a test or anything like that. So you could quickly reference it, so if they ask a question, you have it right in front of you. So the sine of 30, just look right here. Opposite, going back to principle of geometry, that's good to remember SOHCAHTOA, where sine is the opposite from the angle over the hypotenuse of the triangle. Cos represents the adjacent next to the angle hypotenuse. And then tangent is the opposite in the adjacent lengths. So sine of 30, opposite is 1, divided by the hypotenuse, which is just 2. So the sine of 30 is 1/2. Another way you could actually see this written is sine, when you're looking at it as, actually a lot of angles can be written as radians. So to convert an angle in degrees, this would be 30 degrees, to radians, it would be something like 30 times pi over 180, which is 30 pi over 180, right? 30 times pi over 180, which is 30 pi over 180, which equals pi over 6. 3 times 6 is 18, so you can see that it's just pi over 6. 180 divided by 30 is 6. So you could actually see this written as what's the sine of pi over 6, right? Which, same answer, 1/2, okay? Another quick example with this one is cos of 60, or actually, sine of 60. We'll do or we could do tangent of 60 to change it up a bit. Tan of 60 degrees, which in this case we go back to SOHCAHTOA, opposite over the adjacent. So opposite of 60 is rad 3. Adjacent, right next to it, not the hypotenuse, is 1 over 1, so it's just rad 3. So that's some ways you can use the first principle. Now going back to the second principle would actually be a 45, 45, 90 right triangle, which is also another one that is pretty easy to memorize. So going back here, we'll make this the right angle using this triangle. We'll say this is 45 degrees, and over here is 45 degrees, right? Now, 30, 60, 90 degrees, you want to think 1, 2, 3, which is the 1, 2, rad 3 from there. With the 45, 45, 90 degree triangle, you want to think 1, 1, rad 2, or 1, 1, 2. So you know that across from the 45s, they have to be the same, because same angle means the same length. So then across from the 90 degree here, is just rad 2. 1, 1, rad 2, or square root of 2, which makes sense because the 90 degrees should be bigger. So anyway, let's continue. So now it's the same concept. If you want to do the sine of 45, you get 1 over rad 2, right? Opposite over hypotenuse. And you can actually rationalize this, which is just timesing by the denominator, so that you actually get rid of like a radical in the denominator. A lot of times you don't want to leave that there. It's improper to leave that there, but if it's fine, it could be left. So you get rad 2 over 2, but it can also be written as 1 over rad 2. So sine of 45 rad 2 over 2, like I said. So that's the second principle, very similar to the first principle. Then the third principle is actually a graph, which is this is the sine graph. So pi over 2 pi, 3 pi over 2, 2 pi. So now let's say this is the sine graph, because we're actually going to talk about the cosine graph too. They're very similar, but you want to label pi over 2, which is 90 degrees based on you could do that by timesing 90 by pi over 180, like we did earlier with converting degrees to radians. Pi over 2, pi, 3 pi over 2, 2 pi. With a sine graph, you want to go here, middle, above, middle, below, middle. It may be hard to memorize at first, but with practice, it becomes second nature. So it would be something like this based on these values. So this is another way, if they ask you the sine of 3 pi over 2, which is very hard to memorize without drawing it, it actually ranges from 1 to negative 1. So this is 0 here. So you go mid, high, mid, low, mid. So now if they ask for the sine of 3 pi over 2, you know it's negative 1. Goes over there. All right.